Hello everyone, and welcome to lesson 7.3, which is on identifying functions. So, we've talked the last two lessons about different parts of functions. Now we need to really get down into understanding and explaining what functions actually are and what they look like. Now, we've been given the rule that a function is a special kind of equation that says for every x there is only one y. How do we determine that? Well, most likely you are going to be given a set of points, right? We've talked about domain and range in 7.2, especially the very last example of 7.2, where you had specific domain values and specific range values. You might be given a set of points. You might be given a set of just domains and ranges that you have to match up. The best way to determine if you have a function is by mapping them out, right? So when you map it out, we take a look and we say, hey, here's my set of x values listed out. Here are my set of y values listed out. And we just kind of draw arrows matching the points that are connected to each other. So like, for example, like there are three scenarios that could happen when you start mapping values. The first scenario is essentially just like one for one, everything goes straight across, right? Nothing is crossing, no x value is going to another value here. Like that's kind of the basic of it, right? You could also even have something like this at the very end. It doesn't really matter. They don't have to go straight across. Like we could crisscross them if we really wanted to. But what we see is that 1 matches with 7, 2 with -5, 3 with 18, 4 with 2. And we're good, right? For every x value, there is only one y value that goes with it. All right? The next thing that we have could look like this. I could have 3 go into 1. I could have 7 go into 9. I could have 5 go into 11. And I could have 1 going to 9. Now that looks a little messy, right? Mainly because, our friend 7 here got left out. That's okay. Doesn't matter. The rule is for every x, there is only one y. So let's ask ourselves, is that the case, right? So if I went down the line here and I looked at x, is there only one y matched up with 3? Absolutely. Just one y is matched with 3. Cool. I move on to the next one. With 7, is there only one y matched with 7? Sure. What about 5? Yep, only one y matched with it. And what about 1? Yeah, only one y matched with 1 too as well. So even though we do have this weird scenario where two x's are going to the same y value, those x's are only matched to one number each. And that's okay. Two x's can share a y. And let's write that down. So we have that. Two x's can share a y. Now, the third thing that we'll see sometimes when we map functions is this. We might have 5 going to 2, right? We'll have 1 going to -4. We'll have 1 going to 6. And then we'll have 2 going to 11. Okay, again, I know, right, our friend 3 is left out here, whatever. Doesn't really matter. If the rule is for every x there is only one y, look at what's happening at 1. 1 is getting matched here, and it's getting matched there. That's a problem. That's an example of something not being a function. Here, 1 cannot be in 2 places at once. Right? Think about it. Other than standing on the border and straddling, like having 1 foot in one state and 1 foot in another, you cannot be in 2 separate places at once, right? It is impossible for you to be in California and in Florida. Can't be done. So, the same way, whenever we're looking at functions and mapping things out, you cannot have one number being split or one x value being split into 2 separate locations. That is not okay. Essentially, what ends up happening here is our first example is a function. Our second example is also a function, but our third example is not a function. So, we just have to be really careful with how we show things and explain things. Mapping is probably one of the most straightforward ways to do it. All you have to do is write your values out and see if something goes to where it splits. If you see it splitting, going into 2 places at once, that's our situation that's not okay. Okay, let's look at some examples here. These are just different ways to determine if things are functions or not. All right, so determine if each of these are functions. Well, our first example, we've gotten a bunch of points, right? We have 2, 4, we have 4, -4, 2, we have 3, 5, we have 1, 9. So all we have to do is write our values out. Makes it nice and simple. So we'll start with our x values. We have 2, then we have -4, then we have 3, then we have 1. It's important to take a look and make sure that nothing repeats. We can't have repeated numbers in there, right? Because if we do, we need to erase one of them. Then we look at our y values. Y values are 4, 2, 5, and 9. Again, you got to check to make sure nothing repeats. If something does repeat, then you erase the extra one. We can't have any doubles in there. And now we just map everything. All right, so in our first point, we have 2 going to 4. Okay. In our second one, we have -4 going to 2. Okay. In our third one, we have 3 going to 5. That's okay. And in our last one, we have 1 going to 9. That looks good to me. So yes, this is a function. Excellent. All right. Now we move on to number 2. You could get a problem like this with inputs and outputs. First thing I would say to remember is that inputs are always our x's, outputs are always our y's. So we just need to look. The rule is for every x, there's only one y. So start here at 2. There's only one line coming out from number 2. We're in good shape. Now we look at number 1. There's only one line going from number 1. That's okay. And then 3. There's only one going out from 3. Again, we're in great shape. We do have 2 x's sharing a y, but as we've covered, that's okay. So this is also a function. All right, and then our last example here, we'll scroll up a little bit. It says, find the equation that relates x to y. If it is not a function, write not a function. All right, so the first thing we have to figure out is this equation a function? Yes or no? So we need to do what we've done in problem number 1. All right, we're going to start and we're going to write our x's out. Our x values are 2, 4, 6, and 8. Then our y values are 2, 8, 14, and 20. When I match those up, 2 goes to 2, 4 goes to 8, 6 goes to 14, and 8 goes to 20. All right, so great. We know it's a function. That checks out. So now what we have to do is find the equation that relates x to y. So basically we have to do what we did back in chapter 6 and in lesson 7.1 when we were writing out equations. We need to start by finding our slope. So we pick 2 points. It doesn't matter which 2 points we pick. I'm just going to start with the first 2 here, which is 2, 2, and 4, 8. So that's going to end up giving me 2, 2, and 4, 8. Label those out, x1, y1, x2, y2. Let's go ahead and find my slope, which is going to be 8 minus 2 over 4 minus 2, which ends up being 6 over 2, which ends up being 3. All right, so I've got my slope. That's good news. So I got my slope. I also have a point, so I can put this thing into point slope form, which is y minus y sub 1 equals m times x minus x sub 1. That's our equation of a line that we talked about back in chapter 6. Y minus y1, which is 2, equals our slope, which is 3, and then x minus x sub 1, which is 2. All right, we'll zoom in here just to get a little more room, get some clarity. And from here, we just simplify. We do a little distributive property on the right-hand side. That ends up giving me y minus 2 is equal to 3x minus 6. And then we add 2 to both sides. And we get y equals 3x minus 4. Once we're here, we now have the relation for this problem. Find the equation that relates x to y. That equation is y equals 3x minus 4. So, even though we're dealing with functions, even though we're dealing with new things, even though we are having all these new terminologies and all these new notations, there are some things that are still older and familiar that we have to keep coming back to and keep coming back to and keep coming back to. Example number 3 is one of those. While most of the chapter is going to be on looking at if something is a function or is not a function, you might also have to do some older calculations that we just can't forget about. All right, so hopefully this has helped you with this section and has been able to help you with 7.3. If you have any questions for me, please don't hesitate. Reach out and let me know.